Hi, this is Aditya and we are going to discuss about rapid spanning tree protocol. In previous section, we have taken a look about the legacy spanning tree protocol feature or enhancement, because we know very well a legacy spanning tree protocol or spanning tree protocol may take up to 1 minute to converge. Because of that, we can use port fast, uplink fast, and so on and so forth. That feature we have available. But even then, if you configure normally, if you're not going to use any of feature inside your spanning tree, so that may take up to 1 minute time to converge. So if you running an application that is time sensitive, that may cause the problem. That's why rapid spanning tree taken place. But here we are going to the customize, or I should say the proprietary version, to discuss about the proprietary version of rapid spanning tree protocol, that is the CISCO. So the objective of video, the rapid spanning tree concept in working, rapid spanning tree protocol configuration, verification and troubleshooting. So first let's discuss about what is rapid spanning tree protocol, what changes taken place inside your rapid spanning tree protocol that is not usual as legacy protocol. So it defined new standard that is known as 802.1W, and later it known as 802.1D 2004. It has faster convergence than rapid spanning tree protocol or legacy spanning tree protocol, because it use a proposal method so that they can going to figure out as soon as possible who is going to become root bridge and which port I should configure as a root port, and so on. It simplify the port state. It also adding new port role. If you discuss about, or if you compare about spanning tree protocol, the way of path selection is as it is. It also uses cost to determine which is the best path. So the behind the scene, the cost of link are the same and the way of selection is same, because that makes sense. We know very well the higher speed cost, sorry, the higher speed bandwidth is a lower cost of the link. So now this is time to compare about legacy spanning tree protocol and rapid spanning tree protocol ports state. So in legacy spanning tree protocol, we have disabled blocking, listening, learning and forwarding. These are the state that we have available. Because of that, it may take up to 1 minute time. But if we talking about rapid spanning tree protocol, there is discarding, learning and forwarding. That makes sense. The discarding is equivalent as a blocking or disabled, and learning is equivalent of listening and learning. And then forwarding is as it is, that sending data or normal traffic originated by the user, not by the switch actually. If we discuss about the rapid spanning tree port role, it has one new port role that known as backup port. So the root port is as usual, the port which is facing direction of root bridge to get to root bridge. Alternate port, the redundant link or the alternate link that facing to root bridge but the currently state of discarding. But there is an enhancement, or I should say the feature or the way of working of rapid spanning tree protocol. The alternate port is already working as a uplink fast. That means if let me go through the example that makes sense a lot. If we have a switch 1 and this is the root bridge, and another we have switch 2. and there is port number 1, port number 2 on both of switches. So if it is working as a root, these two port going to work as a designated, and port number 1 going to work as a root, because by default cost going to tie up and priority going to win. And port number 2 is working as a alternate port. So in legacy spanning tree protocol, what happen if the link number 1 is goes down, link number 2 may go through the listening, learning, and then after forwarding. So that may take little bit time to forward the data out of this direction. If we enable uplink fast out of both of switches, or particular this one in this case, so that means they actually already know where is root bridge located. So I am not going to wait a longer, because I know where is the root bridge. Immediately I am going to mark this interface or configure this interface as a root port. But in rapid spanning tree protocol, you don't need to do this, because this is already working as an uplink fast. So that makes sense in case of if we using rapid spanning tree protocol. Designated port, a port which is direction of non-root bridges. That is as usual like legacy spanning tree protocol port states. The new thing that we're going to discuss about the backup port. This is the new port role inside rapid spanning tree protocol, or I should say this is the different one if we compare with legacy and rapid spanning tree protocol. So backup port is also a backup of designated port, a direction of non-root bridges, and also when the device is not aware about spanning tree protocol. I think the line is not enough to make you understand. That's why I'm looking to show you this practical, or I would like to verify this on I should go through the packet tracer, because I do not have any device that I can connect to my topology so that I can show you the backup port. So that's why I had configured the topology. We have switch 1, switch 2, switch 3, and obviously we have a hub. So hub, as we know very well, this is not aware about spanning tree. So if you sending any BPDU message, I'm going to send you back, because I do not have logic running behind the scene. I do not have any kind of software that going to take decision. So the rapid spanning tree protocol, these port are actually the root. Sorry. These are the designated root, and this should be the designated both. These are the alternate. This is also working as a designated, but this one is working as a backup port. So let's verify by the command. On switch 2, this is port number F6 and this should be F5. Yep, sure enough. So let me execute command. So spanning tree protocol, we can say F0/5 and 6 both are the share link. That means they are connected with half duplex media or a hub, and one of port is going to work as a backup, because F0/1 going to win and become the designated port. F0/6 is not going to become designated, because if it going to work as a designated, that may cause the loop. So because of that, the backup port is going to elect. So backup port means the backup of designated, that's similar to the alternate port of the root that goes to the same direction of root bridge. This is the new port role that introduced in spanning tree or rapid spanning tree protocol. So now let's discuss about what enhancement available in rapid spanning tree protocol. We can configure a particular port as a ACE port. An ACE port is a similar as port fast. The configuration is as it is. You don't need to execute special command because backward compatibility. Since spanning tree protocol also compatible with spanning tree protocol, sorry, rapid spanning tree protocol is also compatible with spanning tree protocol. So it fall back if it not getting the proposal reply back out of particular interface. So let me show you actually, let me discuss this one and then after going to describe or discuss about the compatibility and all those things. In rapid spanning tree protocol, we have two link type. The port which is non-edge, that means this is not going to connect any host. This is actually going to connect a device which is switch or a hub. In this case, we have point-to-point link and shared. A point-to-point link is also known as half duplex, as we seen the device which was connected with hub can be used. Sorry, this is full duplex. The device that is connected to the switch, I should say, that can be used for rapid spanning tree. So means if we have a point-to-point link working full duplex, not working full duplex, that can be work with rapid spanning tree protocol. The link which is working as a half duplex, that automatically going to fall back in legacy spanning tree protocol. So your switch automatically going to figure out this port is not longer part of rapid spanning tree protocol. I'm not going to behave as rapid spanning tree protocol. I should fall back in legacy spanning tree protocol. So how does rapid spanning tree protocol work? Let's see. Rapid spanning tree protocol uses proposal system for faster convergence. Every switch generate BPDU. That means if any topology change occur, you are not longer waiting to get message from the root bridge to make the changes. You directly going to figure out which path is the alternate and the best one if any changes occur. So because let me go through the example then after. So in spanning tree protocol or legacy spanning tree protocol, if this device is working as a root bridge, and let's see we have another switch connected to these links. Okay, so what happened, consider this port is working as a root and this one is a alternate. So what happened if the root port goes down? They not immediately going to figure out which is the alternate link. They actually waiting to get any message from the root bridge or any other topology. So suppose any other topology taken place or changes taken place, they are wait till root bridge announce that. So in rapid spanning tree protocol, that is not true. If I am not able or not hear any BPDU message after 6 seconds, I come to know that neighbor is no longer available. Now I can automatically going to switch on this link. So if you're talking about the spanning tree protocol or legacy spanning tree protocol, they actually dependent on root bridges. But in case of rapid spanning tree protocol, they also deal with the BPDU message directly. If your neighbor is not sending you the BPDU message, that means the neighbor is no more available. So this is the different, as we can say, in rapid spanning tree protocol. So that's why every switches generate BPDU. That means if topology changes occur, switch will going to find to other link to goes to the root bridge after 3 hello messages. So each message by default going to send out after 2 seconds. 3 into 2 is equal to 6 seconds. So they are automatically going to converged. They not longer waiting for get any reply from the root bridge. And if you're talking about a larger network where we have 100 or more than 100 switches, that may cause the problem if we using rapid spanning tree protocol, because fast the convergence may not work as it work usual. We're going to discuss on it how, because how does it actually got affected if we have a larger network or more number of devices or switches, I should say. So since we are talking about the Cisco proprietary rapid spanning tree protocol or per VLAN spanning tree protocol, but before going to practical, let's discuss about the proposal way or rapid spanning tree working. So the rapid spanning tree working actually, the work of rapid spanning tree is actually they send out the proposal. In what is the proposal? Let assume all switches is rebooted and they are turning on, or that means they're going to start. So each switch going to advertise, hey, I am the root bridge, I am the root bridge, I am the root bridge. So suppose the MAC address of this switch is A, this switch is let's see B, and this one C and D. Everything is the default configuration. So switch B, if first come up, it going to send out the proposal out of every interface. That means all switches. That I am the root bridge. This is my proposal. Switch D going to say yes, since your MAC address is lower than me, you could be the root, and sending the acknowledgement back yes. Okay. The same things happen with C. Okay, your MAC address is lower than mine or whatever I have done so far. Actually, you have only sent me that packets. So for now, you are the root. I'm going to consider you root. And as soon as A is sending that message, switch C immediately going to tell to switch B, hey, I got the lower MAC address value out this direction. So that means switch A should be root, and you also need to configure your port, because these port are going to direction of root bridge. So same thing going to work with D, C. So what happen if link or switch A goes down? Now they again sending proposal that I am going to become the root, I am the root, and I am the root. So they figure out, actually they're going to compare the value, priority and MAC address, and then after they decide which is going to become the root bridge. So in legacy spanning tree protocol, they wait till the message send out of every devices, and they should agree to become this switch as a root. So all they must agree. This is true if you're talking about legacy spanning tree protocol. That means they might need to wait a longer time to take decision who is going to become the root. But in case of rapid spanning tree protocol, as soon as possible, they're going to figure out who is going to become the root. So this is the advantage of rapid spanning tree protocol over spanning tree protocol. So now it's time to verify all those things, and this is the topology that we're going to work with. So I'm going to turn on my devices in going through step by step configuration. All right, my devices is up and working, and now let's go through step by step configuration. So first thing that I would like to show you, I'm going to verify what version of spanning tree we running currently on this topology. So I'm going to execute a command, do show spanning tree out of every device or every switch. That is IEEE on switch 1, switch 2, 3 and 4. So sure enough, currently actually we working on legacy spanning tree protocol or spanning tree protocol more accurately. So you can say if we find IEEE on the devices or switches. So now let me change the mode of spanning tree protocol. Spanning tree mode, rapid spanning tree. Excuse me. Great. Out of every switches. Let's verify again. Now we should have a rapid on every switch. Switch 3, switch 4 and switch 1. And next thing that we're going to do, we're going to configure switch 4 as a spanning tree or a legacy, and then after we're going to verify whether it's compatible to spanning tree or not. So before going to configure switch 4 to work as a legacy spanning tree protocol, I would like to show you something on switch 2. On switch 2, currently the ports are point to point and some of may working as a route, means direction of route bridge, and there is nothing special than the legacy spanning tree protocols output. So right now this is same as a spanning tree protocol, but what happen if switch 4, let's see, spanning tree mode PVST, what happens switch 4 if working as a legacy spanning tree protocol? That means switch 2 automatically going to figure out now switch 4 is working as a legacy spanning tree protocol because I'm not getting the proposal out of this interface, or whatever the appropriate message should I supposed to get out this interface, I'm not getting from the switch 4. So that means switch 4 is actually working on the legacy spanning tree protocol. So immediately I'm going to fall back so that I can work with switch 4 for compatibility issue. So execute the same command, do show spanning tree protocol, and let's see gig 0/2 which is connected to switch 4 is now peer spanning tree protocol. That means I am working on rapid spanning tree protocol or mode of rapid spanning tree, and this port is working as the legacy spanning tree. So this is what the fallback in rapid spanning tree. Next thing that we're going to discuss about the alternate port, because alternate port is already working as a uplink fast. So currently I think which switch is working as a route. Let me execute command out of switch 4. I'm the route bridge. So now I'm going to change back to work as a rapid spanning tree, and then after I'm going to make switch 2 to so that spanning tree VLAN 1, I'm the root primary. Switch 2 is now working as a route bridge for VLAN 1. So this interface actually configure as a trunk port. So one of link work as a root and another is work as a alternate. So let's verify on switch 3. F0/1 excuse me, do so spanning tree protocol. Currently for VLAN 1, F0/1 is a root and F0/2 is an alternate. If I am going to turn off interface F0/1, immediately F0/2 become the root port, and means for faster transition it going to forward data out of F0/2. They are not going to listening and learning. So the interface F0/1 shut and do so spanning tree. Excuse me. Sure enough. Now F0/2 is a root breeze and the state of port is forwarding. So that's good. The convergence is fast because we have already using it as a uplink fast port. What else that we need to discuss? Edge port. The edge port is a port fast. So let's verify whether your rapid spanning tree also going to flush the cam table or not. So first thing I need to check, do so MAC address table which is learned dynamically in VLAN 1. Let me generate some packet toward the network so that populate the cam table. 1, 2. Let me pause to populate the MAC. Okay, I should also tell you switch to gig 0/1 is going to my production network. That means it should populate the MAC address which is the located the device inside my production network. So do so, again I'm going to execute command do so MAC address table, and which we learn dynamically for VLAN 1. We can see switch 1, switch 2, switch 3 and switch 4 we have up to 16, 15, 16 and 15, approximately the same MAC address. In the MAC address I am learning from switch to gig 0/1. So let first verify whether it's working or not. So do so IP interface brief include gig interface only. Excuse me. It should do so IP interface brief include gig interface. Exactly. So F0/1 that is goes to the switch. Sorry, goes to the production network. F0/2 that is goes to the switch 4. So what happen if I'm going to turn this interface off? That is interface gig 0/1. Interface gig 0/1 shut, and then same command do so MAC table. On switch 2 that going to flush out those MAC addresses that belong to that particular port. What about rest of switches? They are not. So that makes sense. That is also advantage of rapid spanning tree protocol. Any flapping link that not going to cause the MAC flash or cam table flashing, I should say. That is not going to clear out your MAC address table. They will going to clear if the default time or the expire time going to cross. So that is also the advantage of rapid spanning tree protocol. And yes, we left the topic edge port. Edge port, the device which is goes to the host. So configuration is same. Let configure spanning tree interface gig 0/1 spanning tree port fast. That's good. And what changes we can see? We will see, excuse me, spanning tree. What command I should execute? Oh, actually the port is turn off, I think. So first no shut, and then after spanning tree port fast. And now do so spanning tree, the edge port. We can see gig 0/1 is working as a edge port. So far we have discussed these things. You're talking about rapid spanning tree protocol, what is new in rapid spanning tree protocol, how we can configure, verify, and also troubleshoot. The root port alternate designated, and the backup is as it is. Alternate has the feature already working as a uplink fast, and rest of things is as it is. So I hope this is informative for you, and thanks for watching.